Video, we're going to go ahead and discuss complex numbers using our imaginary numbers and all of that fun stuff. So what this says right here is remember that A and B are real numbers. That means that if I have A plus BI, so a real number plus a real number times an imaginary number, so an I, that makes it a complex number, okay? It's written in standard form when it is written as such, where I have the A plus BI. So the real number plus the real number times the imaginary number. That's in standard form. If B is equal to 0, then that just means it's a real number because 0 times I is going to cancel out the I, right? So B cannot equal 0, therefore, to be a complex number. In order for it to be a complex number, your B must be any number besides 0 so that it does have the imaginary number. And then it's called a pure imaginary number where there's no, yeah, that's the word I'm looking for, when there's no A. So you just have some number times the imaginary number. So like if I had 5i, that would be a pure imaginary number because it's just an imaginary number. There's no complexity to that, if you will. This says I equals the square root of -1. That is the imaginary unit. So let's remember really quick. If I have I, that equals the square root of -1. If I have I squared, that just equals -1. If I have I cubed, that equals -I, and if I have I to the 4th, that equals +1. So just remember those, and then once you get to I to the 5th, it comes right back here to the square root of -1. It's a cycle of 4, okay? So what we're going to go ahead and do here is we're going to go ahead and simplify each one of these problems that I've got right here. And it says perform each operation and express your final result in standard form. So that means that my final answer is going to look like something like this, okay? So here I just have 5 plus I plus 6 minus 2i. Notice none of this is being multiplied, so I don't even need to worry about those parentheses. Those parentheses aren't changing anything right here. So I have 5 plus I plus 6 minus 2i. So I'm just going to go ahead and combine like terms. So that means I'm going to bring the 5 and the 6 together, so that gets me 11. And I'm going to bring the I minus 2i together. Just treat it like an x. If I had x minus 2x, that would just get me -x. So this is just -I. So that's my final answer there. Over here, however, the parentheses are important on this one because I have a subtraction. So that means that I'm going to be subtracting everything behind it. Here I added, that didn't change anything behind it, right? So this is just like having 8 minus I minus 4 minus -I, so plus I. Now, when I go ahead and combine these together, I'm going to have 8 minus 4, so that gets me 4, and -I plus I. Well, that cancels out and just gets me 4. All right, so now let's try this one. This one, it's not just simply combining like terms. It's not just distributing a subtraction sign or anything. I'm multiplying two binomials. So that means I'm going to have to FOIL. So let's go ahead and do that. So I've got 6 times 2. That gets me 12. And then I'm going to do 6 times -3i. So that gets me -18i. And then I'm going to do -2 times 2. So that gets me -4i. And then I'm going to do -2i times -3i. So that's going to get me a +6i squared. Okay, so let's go ahead and combine like terms now. So I can bring down the 12. I can combine this -18i minus 4i. So that becomes -22i. And then anytime you have an I squared or an I to the 4th, you want to change that. Just like we have here, this is -1 or 1. Anytime you have I squared or I to the 4th, you want to do that as quickly as you can. So here I'm going to do that right here. I have 6 and I squared. So instead of I squared, let's change that. What does I squared equal? Well, I squared equals -1. So really I have 6 times -1. So that's -6, right? And so then I'm going to take this a step further and combine one more time. So I'm going to do 12 minus 6, and that's going to get me 6. And then I just bring down the -22i. And there's my final answer, 6 minus 22i. Okay, now if we come down here, we can go ahead and do this one. All right, so right here, we're just going to have this negative AI, and it's being distributed to what I have behind here. So we're going to go ahead and distribute that to both of these. So negative AI times 9 is going to get me negative 72i. And then now I have negative AI times positive 4i. And so then that's going to go ahead and get me negative 32i squared. Now, just like on the last one, as soon as I have something that's I squared or out of the fourth, I want to get rid of that and turn that into a negative 1. So this is no longer I squared, and I'm just making this a negative 1. So now I have negative 32 times negative 1, so that becomes a positive 32 minus 72i. Notice the way that I changed this was I put this 32 in front and I put the 72i in the back because this is writing it in standard form. This is a plus bi, okay? All right, number 5. I've got 4 minus 7i squared. Now, remember that square just doesn't just come in like this and just do that. No, no, no. That's saying that I have 4 minus 7i times 4 minus 7i. So now it's just like this problem that we did before where I had to FOIL. You've got to distribute, okay? So now I'm going to go ahead and do that. So that gets me 4 times 4 is 16. And then I'm going to have 4 times negative 7i, so that's negative 28i. Then I'm going to have negative 7i times 4, so that's a negative 28i. And then I have negative 7i times negative 7i, so that's going to get me a positive 49i squared. So now we're going to go ahead and combine like terms, and we're going to replace this I squared with a negative 1. So now we're going to have 16. Negative 28 minus 28, that's going to get me to have a negative 56i. And then, like I said, we're going to just go ahead and replace that I squared with a negative 1, so that becomes minus 49. So then my last step is to go ahead and combine the negative 49 and the 16, and that's going to get me negative 33 minus 56i. Again, written in standard form, a plus bi. Number 6. Now, this one's a little bit weird because if you don't really know some of the rules, then it's easy to forget. This right here, remember I right here is the same thing as having a square root of a negative 1, right? And so if I had 14 over the square root of 3, for example, you'd have to rationalize that, wouldn't you? You can't have a square root in the denominator. Well, I can't have an I in the denominator because that's the same thing as having a square root. So instead, we have to go ahead and multiply it out and get rid of it. So what I'm going to do is I'm going to multiply by the conjugate of it, which is just changing this to a negative I to both the top and the bottom. So if I do that, that gets me up top 4 times negative I, so that's negative 14i. And on the bottom, I times negative I, that gets me negative I squared. Okay? Now, negative I squared. Remember, I squared is negative 1, so that becomes negative 14i up top. On the bottom, I have negative 1, so it's really just a positive 1. So my final answer, it's just negative 14i. Because remember, you don't have to write that something's divided by 1. That's just redundant. That's weird. Okay. All right. Number 7. Okay. For this one right here, I have a square root in my denominator because I have a 5i. So I need to go ahead and get rid of the square root in the denominator. So what I'm going to do is I'm going to multiply by the conjugate to top and bottom. So the conjugate is 2 minus 5i to both the top and the bottom. So that means up top here, I'm really just going to take this 3 and I'm going to distribute it here. And then on the bottom, I'm going to end up foiling. Okay. So let's go ahead and just distribute this up here. That gets me a 6. And then when I distribute it right here, that gets me a negative 15i. In the denominator, I'm going to do 2 times 2, so that gets me 4. Then 2 times negative 5i, so that's going to get me a negative 10i. Then 5i times 2, that's going to get me a positive 10i. And then 5i times negative 5i gets me negative 25i squared. So now let's go ahead and simplify things, because right now I have a whole bunch of i's in the denominator. I started with just one, and right now I've got 3 of them. Let's see what happens. Okay, so now negative 10i plus 10i. Well, those canceled out. Those went away. That became 0. And now I have negative 25i squared. Well, I squared is just negative 1. So let's get rid of that and turn that into a negative 1. So really up top, I have 6 minus 15i. On the bottom, I have 4 minus 25 times negative 1. Well, this 25 minus, or I'm sorry, negative 25 times negative 1 becomes positive 25. If you've noticed, anytime you just have a number times an I squared, whatever that number is, once you change that I squared into a negative 1, all you're really doing is just changing this to the opposite sign. So if this was a 5 times I squared, it's now negative 5 and the I squared's gone. If it's negative 13 times I squared, well, this is negative 1 here, so that just becomes positive 13. So really right here, this negative 25i squared, it's just going to become a positive 25, okay? And then I'm just adding that to 4, so I have this all divided by 29. Now, to write this in its finalized, complete standard form, a plus bi, that means that I've got to split this, okay? I have one fraction here, and I have another fraction here. So I have 6 over 29 minus 15i over 29. And if you could reduce either one of them, you would. In this case, I can't. So this is what I have. This is my complex number. This is a plus b. My b is 15 over 29, I. Okay. All right, let's do number 8. Number 8 right here. Same exact kind of concept as what we just did on number 7, except unfortunately, fortunately, however you want to look at it, I have a binomial on top and bottom. So I'm going to multiply both top and bottom by the conjugate of the denominator. Remember, that just means that I'm changing the sign in front of that imaginary number. So it's like going 1 plus 2i. More or less what I'm doing is I'm turning this into a difference of 2 squares. And the reason I'm doing that is so that I can get rid of the I in the denominator entirely, just like you saw right here, where we were able to get rid of this negative 10i and 10i because that cancels them out. So anytime you're doing this, you're just doing it to get rid of the square root. That's the same way that you would have rationalized your denominator in our previous unit that we just did. So let's go ahead and do that. So now if I do my numerator, I'm going to do 6 times 1, so that gets me 6. 6 times 2i, that's going to get me positive 12i. Negative 7i times 1, so that gets me negative 7i. And negative 7i times 2i, so that gets me negative 14i squared. In my denominator, I'm going to do 1 times 1, so that gets me 1. 1 times 2i, so that gets me 2i. Negative 2i times 1, so that gets me negative 2i. And negative 2i times 2i, so I have negative 4i squared. So remember what I just said just a minute ago. If I replace this I squared with negative 1, I'm really just changing the sign of what I have right there, okay? So then I'm going to go ahead and combine where I can. So now I really have 6 plus 14, so that gets me 20. And then I have 12i minus 7i, so that's going to get me plus 5i. And then I'm going to go ahead and do the denominator. And the denominator here, I'm going to have 1 plus 4, And then this 2i minus 2i cancels out. So this becomes 5. And now I'm going to go ahead and split this. If you notice right here, I could reduce right now. I can reduce this term and this term by 5. Okay, that's not canceling anything out that I shouldn't cancel out unless I only canceled the 5s and didn't reduce anything here. But if you're scared that you might accidentally reduce something that you shouldn't, split it, then reduce it. So if you see this here, 20 over 5 is just 4. 5 over 5 is just 1. So I have 4 plus I. And there's my final answer. Okay. Now, let's go ahead and see what we've got below this here. So below this here, we're supposed to go ahead and plot our values on our complex plane. The complex plane is no different than having an XY coordinate grid. The only difference is that the horizontal axis is going to be your real axis, and where it would be a Y coordinate is our imaginary. Okay? So if I have it set up like this, if I was to plot this, I'm going to take this and turn this into a coordinate just like this. It would be -4, +2. So you see, I'm going to plot this -4 on this real axis, and I'm going to plot this 2 on this imaginary axis as if it was an X and a Y. So in this particular case, I'm going to go -4. So 1, 2, 3, 4, and I'm going to go +2. 1, 2, right there. So this would be number 9 right here, and that's at -4 plus 2i. Now I can go ahead and plot this one right here. It's at 3, -5i, so that's right 3, down 5. So we would go 1, 2, 3, and then 1, 2, 3, 4, 5. Right here would be number 10. That's at 3, -5i. My last one to plot here would be just this -7i. Well, what's my real number that I would have? What's my A? If it isn't there, it's 0. This is a pure imaginary number, and so I have no A value, and so it would be no different than if I gave you the coordinate point of 0, -7 to plot. So instead, I'm just going to go straight down 7. So this is -5, 6, 7. So I'm going to be right here for number 11. Okay. All right, so now here what we've got is the absolute value, also called the modulus or modulo of a complex number. You're just taking, basically, if you want to think about it this way, you're taking the Pythagorean theorem more or less, okay? So it's if you were doing the magnitude of a vector, it's the same kind of concept. So right here, if I have 3 minus 5i, if I plotted this right here, that would be going right 3, 1, 2, 3, and down 5, right? 1, 2, 3, 4, 5. So it would be right here. And it wants me to take the absolute value. So if I go ahead and draw a triangle right here, this would be 3, this would be -5. And it's wanting to know this. The absolute value represents our distance from the origin, okay? It's our length. How far away is that particular imaginary number, that complex number? Where is it located on our imaginary plane? Well, that's what we're doing right here. We would be solving for the length from 0, okay? So in order to do this, we're just going to go ahead and just do, I've got 3 squared plus -5 squared, and we take the square root. So now I have 9 plus 25, and I take the square root of that. So that's the square root of 34. Remember, you always check to see if there's anything that you can do to further simplify it. And in this case, I cannot further simplify the square root of 34. There's no perfect square I can evenly divide out. Okay. Now, this last little thing right here is it says this, that sometimes some textbooks or notes, or even, we don't know necessarily, maybe even College Board will use the double bars for absolute value to indicate modulus, just like they do sometimes for vectors when doing the magnitude of a vector. They sometimes use the double bars. So if you ever see that where it's just saying find the, and then it has an absolute value of something right there like that, that's just asking you to take the square root and do like Pythagorean theorem, okay? And that's finding the modulus. Hopefully this was a good enough review and you're ready to go for our class on Monday.